Hi everyone, in this video we are going to discuss about asymmetric encryption algorithm, which is also known as public key encryption. So we have discussed in some other video that encryption is used to convert our original message into something secret so that nobody can be able to read the contents. For that we use encryption, and for this encryption we have generally two methods. One is symmetric encryption algorithm, second is asymmetric encryption algorithm. And in this video we are discussing that asymmetric encryption algorithm or the public key encryption. For demonstration purpose, we have taken these two users, one is Bob and second is Alice, and they want to send each other a private or secret message. And for sending the secret message to each other, both of the users will generate a pair of keys. So let's say here both of the users are using some algorithm, and with the help of that algorithm they will be generating a pair of key. Let's say this Bob is generating a key. First key is known as public key and the second known as is private key. In the same way, the second user Alice will also generate a public key, and Alice will also generate a private key. Now the important thing is that message encrypted by one's public key can only be decrypted by his or her own private key, or maybe encrypted by a private key that will only be decrypted by the public key. So let's say if this user is going to encrypt some message with, let's say, public key of himself, then that message will only be decrypted by the private key of Bob himself. Now, when both of the users have generated the public and private keys, so now they will exchange the public keys with each other. So let's say Bob sends his public key to Alice, and in the same way, Alice also sends her public key to Bob. And after this step, both Bob and Alice have exchanged their public key. You can see here Bob has received the public key of Alice and Alice has received the public key of Bob. After this, let's say Bob wants to send some message to Alice, then Bob will generate his message, and that message will be used as an input to some encryption algorithm. Let's say here. And in this encryption algorithm, in addition to the message which Bob wants to send, Bob will be using public key of Alice, which he received in the previous step. So the public key will be used to encrypt this message, and at the output they will have the encrypted message. And now you might have got an idea that if this message has been encrypted by the public key of Alice, it means for decryption of this message, we need to have the private key of Alice. It means now this message can only be decrypted by Alice herself because nobody else knows about the private key of Alice. So after this encryption, this message is sent to Alice. Let's say Alice has received this message. And after receiving this message, Alice will be using her private key and will be using some decryption algorithm. With the help of that private key, Alice can recover the original message. Now in this case, the most important thing is that if anyone has encrypted a message with the public key of Alice, then only private key of Alice can decrypt that message. So even though any user in between, they may receive this encrypted message, but I mean, they will not have access to the private key of Alice and they will not be able to decrypt it. And private key was generated locally at Alice's computer, so this was never transmitted to anyone. So there are no chances that someone can intercept that private key. This only possible when some hacker or someone is going to access her machine, her computer, and they can have the access to that private key. So in this case, we can securely transmit our information from one user to another. But if you are sending to some specific user, that information secretly, then we need to have the public key of that entity, and then we encrypt that message with the public key of that entity, and then we send it to that particular entity or the user, and then with the help of private key they can decrypt it. And now if you see that if you want to send, let's say Alice wants to send this information, let's say I'll just draw it. So if Alice wants to send something to public, to Bob, then Alice will be encrypting that message with the public key of Bob, which she has received in maybe previous step. Then she can also, then after encrypting this message, she can send this encrypted message to Bob. And since this encrypted message was encrypted using the public key of Bob, it means Bob can use his private key to decrypt that message, and he can recover the original message. And one more thing that we have demonstrated this, that the sharing of public key is done using a direct communication between these two users. So they exchange the public key with each other directly, but there may be the case that we can have a server here, public key server, any common server, where Bob can put his public key and Alice can put her public key. So now anyone who wants to communicate with Bob or Alice, they can access that public key, and then they can encrypt that message with their respective public key, and then they can send the intended destination. And the intended destination will use his or her private key to recover the message. So that was some brief discussion about asymmetric encryption algorithm, also public key encryption. And I hope this was a bit helpful for some of you. And thank you very much for your time. Hope to see you in some other video.